All right, you're welcome to our today's class. Good afternoon. You're welcome to our today's class. Today, we look at electrolysis. Okay, you are done it here?
Yes.
Wow. You know it now, Shay?
Yes.
Have you done it? Huh?
Yes, I've done it, but it's a long time.
When was that? When was that?
That's
No, you. Is it here?
no.
So if I give you a question on electrolysis, can you solve it?
No, I will come to it. I cannot do
So what do you say? Do we do it or do we get another topic? We should do it. You don't know. You're not sure again whether you know it or not. Okay, let me know whether you know it. I don't ask you what is the electrolysis. Oh yeah, close your book. What's the electrolysis?
I don't remember. I will not lie.
Eh? Is what? You don't know. State first law of electrolysis.
What were you going to say that when a substance passes through?
State it.
Because I cannot remember.
You people don't know electrolysis, so let's do electrolysis. Let's do what? Electrolysis, you don't know it. Let's do electrolysis. Oh yeah, put down. Electrolysis can be defined Yeah, right. Electrolysis can be defined as the chemical decomposition Electrolysis can be defined as the chemical decomposition of a compound. Electrolysis can be defined as the chemical decomposition of a compound which takes place when an electric current is passed through either a solution or the molten form of the compound. See spelling of molten here. M-O-L-T-E-N. It's passed through either a solution or the molten form of the compound. Form of the compound. Where's the chemistry note?
My chemistry note. I didn't bring it back at all.
You didn't know that you have chemistry today?
Huh?
You didn't know?
Yes, I don't know. I don't know you also take chemistry.
Okay. I said electrolysis can be defined as the chemical decomposition of a compound which takes place when an electric current is passed through either a solution or the molten form of what? a compound. Now listen carefully. If you have a compound now, something like sodium chloride is a compound. Hope you know. Hope you know. Yeah. Sodium chloride is a compound. Hope you know.
Yes.
Are you aware?
And then which one is not sodium chloride?
Which one is sodium chloride? I don't understand your question.
Sodium chloride, Gabby.
Uh,
I just say sodium chloride.
you thought I said what?
Sodium chloride.
No, sodium. Sodium chloride is a compound. Sodium chloride is your normal salt now.
Yes.
Use it in food. Yes, in cooking. Now, sodium chloride now, if you see sodium chloride at room temperature, it's not really that true. So sodium chloride is a solid on its own. You saw it now. The salt you use at home is solid. I want to explain solution of a compound and molten form of a compound. What do you understand by solution of a compound? And what do you understand by using sodium chloride now as an example? What do you understand by the term solution and the molten form? What do you understand by it? I'm asking you. Tell me. These two terms are in this definition I gave. So that's why I want you to understand. Because if you don't understand if you don't understand any word in any write-up or definition, you may carry the definition in your head, but you don't know what it is. True of us, because you don't understand every word in that the definition. If you can say that you know that definition, that's why I want to explain. But I'll ask you now, since you don't know it. Now, when you say a solution of a compound, it means that, like sodium chloride now, if you get sodium chloride now and put in water, it will dissolve. Both solution and molten, they are both liquid. Then we have three states of matter. We have solid, liquid states, and gaseous states. Now, both molten and solution, they are liquid form. They are in liquid form. But the difference is that if you get sodium chloride now, for example now, and put in water, it will dissolve and form what? Solution. But if you get sodium chloride and heat it for a very high temperature, it will melt and form a what? Molten form. Is that clear? Is that clear? You say, well, now if I carry you now and hit you, put you in pan, hit you, the time will come, you become from solid, you change to what? Liquid. That's molten form. Is that clear? Yes. So molten form is getting from melting the thing. It will not by putting it in a solvent like water to dissolve. Is that clear? Yes. So that's why he said that electrolysis is when you pass electric currents through compounds like sodium chloride now, whether in the molten form or in liquid form, you pass an electric current through it, it will decompose. Decomposition means that the sodium and chlorine will separate. That's chemical what? Decomposition. Is that clear? Is that clear? No. So that's what happens in what? Electrolysis. Now, based on your syllabus, there are some things I want us to compare to do, following what you have in your syllabus. Your syllabus wants us to show the comparison between electrolytic cell and electrochemical cell. So that should form our next topic. Our next subtopic. Right. Comparison between electrolytic cells and electrochemical cells. Electrolytic cell. Electrolytic cells and electrochemical cells. Comparison between electrolytic cell and electrochemical cell. Are you good? Huh? Okay. All right. Now, before you can understand, before I can go into this, I will describe how what a electrolytic cell is and what a electrochemical cell is. Is that clear? So I'll bring it down to a layman understanding. Maybe we have defined electrolysis, right?
Yes.
That this electrolytic cells looks like this because you may not have seen it. It looks like this. Let me draw how it looks like. Electrolytic cell looks like this. Something like this. You have cell attached to electrodes. Can you see the board? Attached to electrodes. Noise has ended. Let's go in. Get my back from me. Their noise has ended. Let's go there. So I can draw this on the board so you can see clearly. Get that duster. Okay, use this one. Don't worry. So it looks like this. You have these two things are the electrodes. Are the what? Electrode. We have this thing you see here is the electrolytes. Electrolytes. This is the cell. These two things are electrode. One is called cathode. One is called what? Anode. The positive one is called anode. This is anode. Negative one is called what? Cathode. This is how electrolytic cell look like. This is a sketch of what? Electrolytic what? Cell. This is a sketch of what? Electrolytic cell. So electrolytic cells are used. They are used to carry out the process of what? Electrolysis. Is that clear? They are used to carry out what? Electrolysis. These cells are used to carry out what? Electrolysis. Is that clear? Now, but the electrochemical cells, they are your batteries. Those batteries you see. You know what battery is now? Both your Tiger battery, all those batteries, there are different types of electrolytic cells, electrochemical cells. Both the battery you put in your car, that car battery, all those ones, ranging from the small one, your finger battery to that big one, they are all what? Batteries. They are the one we call what? Electrochemical cell. They are the one we call what?
Electrochemical cell.
Electrochemical what? Cells. Is that clear? So, electrolytic cell is used for electrolysis, while electrochemical cells is their battery. Is that clear? Is that clear? Now let's compare two of them. All right, so the first, number one, electrolytic cells. Electrolytic cells. Electrolytic cells use electrolytic cells use an external power source. Electrolytic cells use an external power source to drive a chemical reaction. Electrolytic cells use an external power source. Electrolytic cell, this one, use an external power source. External what? Power source to drive
the
chemical reaction. While electrochemical cells harness energy. While electrochemical cells are you there? You just say harness energy. Okay, thank God. Continue. While electrochemical cells occurs on its own, wait, I'm coming. No face, I'm coming. Okay, sorry. Why clean this thing? Clean this from occur. Clean that occur. Then continue. Why electrochemical cells harness energy from a spontaneous chemical reaction? Why electrochemical cells harness energy from a spontaneous chemical reaction? Why electrochemical cells harness energy from a spontaneous chemical reaction? Why electrochemical cells harness energy from a spontaneous chemical reaction? Why electrochemical cells harness energy from a spontaneous chemical reaction? Is that clear? Huh? Okay. Number 2. The reaction in electrolytic cells, is non-spontaneous. Is non-spontaneous. Is non-spontaneous, meaning that it would not occur. Meaning that it would not occur on its own. Meaning that it would not occur on its own without the external energy source. Meaning that it would not occur on its own without external energy source. Meaning that it will not occur on its own without external energy source. Why the reaction in an electrochemical cell, is why reaction in an electrochemical cell
Why the reaction in an chemical cell is self?
Okay, I'm coming. Let me go to rows because I'm seeing different things. I'm coming. You wrote that electrolysis. What I writing is not what I'm calling it. You said the electrolysis used and is that what I said? I said electrochemical. This is an electrolytic cell, and you're writing electrolysis. Sorry. Okay, see, I've seen really. See what this first one, electrolytic, you don't write it well. Electrolytic cells use, and please, if there's any spelling you don't understand, please call my attention. Don't write what you don't know, please. I beg you. Electrolytic cells use an external power source to drive a chemical reaction, while electrochemical cells, this is where Novus come. Where electrochemical cells, where reaction. Okay, see what you do. Why reaction? Put reaction here. In an electrochemical cell, continue. Why reaction? Good. Why reaction in an electrochemical cell is, sorry, give me. Why reaction in an electrochemical cell, sorry for this cancellation. I want you to get it right, okay? Why reaction in an electrochemical cell is self-sustaining. Is that clear? Meaning, right. Yes. Why the reaction in an electrochemical cell is self-sustaining. Look at self-sustaining here, please. Is self-sustaining, meaning that it occurs on its own. Meaning that it occurs on its own. Meaning that it occurs on its own it occurs on its own without an external energy source. Meaning that it occurs on its own without an external energy source. Meaning that it occurs on its own without an external energy source. Is that clear? Please thank you for the question. The point I'm trying to make here is that in an electrolytic cell, change that into, okay, we have done that. In an electrolytic cell, the reaction there needs external energy. That's why there's battery here. Look up to bring electrical energy into this electrolytic cell. Is that clear? Without this power source, there will be no current. No current will enter here. True of us? Now, so because of this energy, it needs an external energy source. That's why sometimes it is taken as a forced reaction. You see, they force it. It's a forced what? Reaction. Force. Because you need external energy what? source. Is that clear? But unlike electrochemical cells is self-sustaining. It's not, the reaction there is not forced. It doesn't need external energy source. Is that clear? Is that clear? Then number two. Okay, the reaction in an electrolytic cell is non-spontaneous. That's good. Reaction in an electrolytic cell is non-what? Spontaneous. Meaning that it would not occur on its own without an external what? Energy source. Are you there? Now, while the reaction in electrochemical cell harness energy. See on the board. While the reactions in an electrochemical cells harness energy from a spontaneous chemical reaction. Harness energy from a spontaneous chemical reaction. Harness energy from a spontaneous chemical reaction. Is that clear? Okay. Number 3. Number 3. Electrolytic cells are used. Electrolytic cells are used for electrolysis. I've said that before. She? Yeah. Electrolytic cells are used for what? Electrolysis. Electrolytic cells are used for electrolysis, which involves the decomposition of a substance using electricity. Which involves the decomposition of a substance using what? Electricity. Electrolytic cells are used for electrolysis, which involves the decomposition of a substance using what? Electricity. While electrochemical cells generate electricity from a chemical reaction. So you look as if electrolytic cells and the electrochemical cells are opposite of each other. Have you noticed that?
Yes.
You look as if they are what? Opposite of what? Each other. Look at this one now. Why electrochemical electrolytic cells make use of, takes in electric energy to to split what? To split what? Chemical substances.
Yeah, why the electrochemical cells generate
Why electrochemical cells generate electricity? Is that clear?
yes.
Examples of electrolytic cells include the ones used for the electrolysis of water. Example of electrolytic cells. Example of electrolytic cells include the cells used in the electrolysis of water, electrolysis of dilute H2SO4. You know what H2SO4 is, right? You know what H2SO4 is, you? That are also subbasis acid. You don't know? Don't worry. We'll get there. Electrolysis of what? Water.
Elements of
H2SO, etc. While examples electrochemical cells. While examples of electrochemical cells include batteries, such as alkaline or lithium-ion batteries. Such as alkaline or lithium-ion batteries, which convert chemical energy into electrical energy. Which converts chemical energy into electrical energy. It's clear, right?
yes.
Is there any question here? Huh? No question. Are you sure?
Yes.
Okay.